So I will start with the first presentation, which is going to be recurrent neural networks. From now on, I'll call them RNN. So the plan is the following. We will start with some motivation. So we will start by looking at which kind of problems we are trying to solve. And we will also see some examples of these problems in real world. We will then see what happens if we try to use the architecture that you have seen so far in the previous days in this school to solve these problems. And we will highlight some disadvantages there. And this will motivate the introduction of RNN, which will happen in point number 2. So we will introduce RNN by looking at the definition, but we will also jump right away into one example, a step-by-step example. So we will make sure to understand the key components that are behind the RNN. And we will then make our way towards formalizing this architecture until we will be able to see the equation that govern this architecture. And at this point, we will know which kind of problems we want to solve and how RNN is solving them, but we still don't know how to train RNN. And this will happen in point number 3. So in point number 3, we will see that RNN follows the usual deep learning way of training, so compute the error and then backpropagate. But there are 2 key aspects that come from the nature of the RNN that we need to consider if we want a correct backpropagation. In point number 4, we will see that the training of RNN can become unstable. And we will see which kind of issues we can have there. And unfortunately, we will see that there is one issue in particular that we are not able to solve with this architecture. So in order to overcome this problem, in the next point, we will introduce more complex RNN architectures, the long short-term memory, so LSTM, you may have heard about it, and also the gated recurrent unit, so the GRU. And we will see how these architectures are more complex and more flexible and are able to solve the issues in the previous point. In the last point, we will see how to make RNN more deep. So which kind of technique we can use to make this architecture able to approximate even more complex functions.